Welcome to lesson 71. We're going to talk about data distribution and outliers. So while I'm modeling, watch to see how I calculate the range accurately, how I identify any outliers and explain it in the context of the data, as well as tell the difference between a negative skew and a positive skew. We're going to look at data samples today that are very visual, and for some data, if it's perfectly distributed, it will be symmetric. So for example, looking at this set over here, I can split this data right down the middle and both sides will be pretty equal. Like you could see, they're exactly the same. On this end, I have 1, 2, 4. On the other side, I have 4, 2, 1. It is perfectly even on both sides. But sometimes data doesn't do that. A lot of times in real life, we have more chaos, and so data might be moved over. So here, we have a cluster of data between 4 and 8, but you can see that some of it is over here on the end, pulling it slightly, and some people call it like a little tail, and we call this skewed left or a negative skew. On the right side, we have data that again is clustered between 1 and 4, but then you get some outliers that skew it in the other way. These are skewed right. And again, some people like to think of it as a tail, like what's pulling it over. If there's a pull to the right, it's skewed right. If there's a pull to the left, it's skewed left. And you could also use the term positive or negative skew. So if it skews to the right, it's a positive skew. If it skews to the left, it's negative. And we're going to use this information to describe the data set. So we're going to look for clusters, we're going to look for outliers, which are ones that are farther away, and we're going to look at the shape of the data. Here are two data sets of temperatures in two regions of upstate New York. Calculate the range and median for both regions. Describe the data distributions for both regions in distribution terms. So I'm going to use terms like cluster, gap, peak, and outliers. So pretty much I'm describing the data as is displayed. I can tell we have two dot plots, so I can see every single point. I can see the number of points that are there, and I see there are 15 for both. My n is 15, so I have 15 data points in here. And I could also see just by looking that these are not symmetrical. So I'm going to calculate the range and median for each using the data that I see on the dot plot, and we know how to find both those measures. And I'm going to look for skewness and see where the data is actually clustered. Is it symmetrical? But no, these are not symmetrical, so there will be a little bit of skew happening here. And I'm going to try to identify the mode which should stand out very easily in this visual model. Hit pause and jot this down in your notes. All right, let's start with our range and the medians. We know our n is 15, so I'm going to look for the 8th number in each set. So here's for 1 and here's for 2. In the first set, my maximum and minimum are 31 and 36. So 36 minus 31, my range is 5 in region 1. In region 2, I have from 36 to 42. So 42 minus 36, my range is 6. I'm going to use the range to help me with the shape. Watch what I'm going to do here. So I know my numbers go from 31 to 36, and my second one goes from 36 to 42. I'm going to use the median to figure out if it's in the center or if it pulls a little bit more on the other side. Because remember, median tells me where one half is and where the other half is. So let's look for the 8th number. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So my median is 34. So looking at my numbers here from 31 to 36, 32, 33, 34, 35. It pulls a little bit, just looking at it. It's definitely pulling a little bit more. Half of my data is from 34 to 36. and the other half of my data is from 31 to 34. So it's definitely a pull, a little tail coming, it's skewed left. And we can see it in our data too. You can see that the data is kind of clustering here. There's a peak at 35, and then it kind of pulls here a little bit to the left. And look at where that tail is compared to where my middle is. It feels pulled to the left. So it has a negative skew. Let's look at our second one. So 36, 37, 38, 39, 40, 41. Eighth number again. 1, 2, 3, 4, 5, 6, 7, 8. So 40. 1, 2, 3, 4, 5, 6, 7. So 40 is my median. And again, think about it. Half of my numbers are between 40 and 42, and the other half are between 36 and 40. So this is also skewed left. And you can see it in the data. It clusters over here with a peak at 40. And then pulls this way. So I can see the peak. I can see a cluster. There's a cluster here between 39 and 42. It's more widely dispersed in this region over here. So how am I going to describe all this in words? Neither set has symmetrical data. In region 2, data clusters from 39 to 42. However, the data is skewed left. Ooh, I also should put in the mode is 40. I would have said that before then. In region 1, the peak is at 35, and most data is pretty even from 32 to 35. It is also skewed left. So I just wanted to give some facts, and that's what I did in my explanation. I said it wasn't symmetrical, both have a skew. I mentioned where the peaks are, where the modes are, and if the data was clustered together or more widely spread apart. So hit pause and jot this down in your notes. Let's look at our second problem. The amount of time and hours that Anna practiced the piano each day for 11 days is shown on the line plot. So 11 days is our N. Calculate the median and the range, describe the data. So if our N is 11, our median, is definitely an odd number, so it's going to be one number in the middle, will probably be the 5th and the 6th number is my guess. Again, I'm taking away 1. So 11 minus 1 is 10. 10 divided by 2 is 5. So my median would be the 6th number. One, two, three, four, 5. Here's my 6th one. 1, 2, 3, 4, 5. So this is my median. 3/4. And my range is from 1/4 to 1 3/4. So when I subtract those, 1 3/4 minus 1/4, my range is 1.5. All right. So looking at the spread, this is 1.5 hours since I want to have the units in there. So looking at the spread of data, you can clearly see it clusters here at 1/4, a little bit more at 3/4, nothing, and then bumps a little bit and trails off. So absolutely not symmetrical. I even want to clean this part up a little bit because there's a dip and back up. Absolutely not symmetrical. It peaks at 1/4. The data has 2 gaps. You can see them here. Here's a gap. Here's a gap. Between 1/4 and 3/4. And again, between 3/4 and 1.5. In this case, you can kind of see the pull of it happening here. So we know it skews right. It has a positive skew. Okay, and I have 3 data facts over here. So hit pause and jot this one down in your notes, and I will see you in the next lesson, Math Marbles. Be well.